Question 10. Like most animals, small marine crustaceans are not able to digest all the food they eat. Moreover, the percentage of food eaten that is assimilated, meaning digested, decreases as the amount of food eaten increases. A residual plot for the regression of assimilation rate as a percentage of food intake on food intake, micrograms per day, is shown here. Okay, so I'm just going to make some notes here that this residual plot seems to have a nonlinear pattern. Okay. All right, I don't know if that means anything, but yeah, that doesn't look good to me. Okay, a scatter plot of natural log assimilation versus natural log of food intake is strongly linear, suggesting that a linear regression of these transformed variables may be more appropriate. Right, so this is the scatter plot of the, this is the residual plot for the untransformed model. Okay, and now they're saying that when we transform both variables with natural log, we get a scatter plot that's linear. Okay, all right, below is a computer regression analysis of the transformed data. Note natural logarithms are used. Okay, so this is our intercept, this is our slope, this is our response, and that's our explanatory. Okay, so if we start with y hat equals a plus bx, then what we will have is the predicted natural log of assimilation equals 6.3324 minus 0.6513 times the natural log of food intake. All right, so when food intake is 250 grams per day, what is the predicted assimilation rate from this model? Ooh, okay, so they'll just change the units on us. So this is grams per day before they said micrograms per day. Okay, so let's convert 250 grams per day into micrograms. I'm just going to Google that. All right, 250 grams into micrograms. Oh, that's such a big number. 2.5 times 10 to the 8th power. Okay, so just move the decimal 8 places, or in other words, add 7 zeros. Okay, 2, 5, okay, geez. So this is equivalent to 2, 5, 1, 2, 3, 4, 5, 6, 7 micrograms per day. 2, 3, 1, 2, 3, 250 million micrograms. Okay, let's see what happens when we plug that in. Okay, so let's take our model, and now we will use that large number as the input. Okay, so 250 million. All right, let's open up Desmos. And figure this one out. Okay, so let's evaluate all of this on our calculator. So 6.3324 minus 0.6513 times the natural log of 250 million. Okay, so that gives us negative 6.26. Okay, so the predicted natural log of assimilation is equal to negative 6.26. Okay, so now we need to unnatural log this. Okay, so e raised to that, and then e raised to that. Okay, so let's do base e raised to the previous answer. Okay, we're running out of space here, but that gets us, let's resize this. Okay, so that gets us the predicted assimilation is equal to 0.0019. Okay. I don't see any answer that looks like that. So, two things could have happened. Number one, I could have made a huge mistake. Or number two, maybe this is a typo. Maybe they didn't mean to change the units to grams per day. Maybe they really meant 250 micrograms per day. So let's see what happens if we just plug in 250. Okay, so let's retrace our steps. So we're just going to make that 250 now. Okay, so that number is going to change there, and that number is going to change there. Okay, let's go back here, and can I just delete? Oh, I can. Oh, look at that, and then it even updates the other work I did below. Okay, so when we use 250 as the input, we get 2.736 as the output. But then, of course, we still have to unnatural log that. So use base e raised to that value. And then we get 15.43. All right, let's look at the answer choices. Okay, there is a 15.4. Okay, all right. So I'm under the impression that that is a typo and they really meant to say micrograms per day there, right? Why would they all of a sudden change the units like that? Like, unless they wanted to be really mean, but yeah, it's probably just a typo.